When graphing trig functions, there are a few things we need to keep in mind. Starting off with the sine function. In this case, we're graphing on the interval from negative 2 pi up to positive 2 pi for the theta values, for the measures of the angle that we're considering. Sometimes they ask you just to sketch one cycle, sometimes they say sketch 2 cycles, sometimes they ask you to have the x-axis be measured in degrees instead of radians, so you just need to adjust depending on the directions of the question. Now in this case, we're graphing y equals negative 2 times the sine of 4 times theta. So my a value is negative 2 and my b value is 4. Now the amplitude is just the absolute value of the a value. So the amplitude in this case is going to be positive 2. The period for sine and cosine functions is 2 pi over the b value. The b value in this case is 4, so that means it's 2 pi over 4, which reduces down to pi over 2. So the period is pi over 2, meaning it takes pi over 2 radians, that's the distance on the x-axis that it takes to complete one full cycle. The number of cycles that occur from 0 to 2 pi are basically just the b value. So in this case, 4 cycles occur from 0 to 2 pi. So starting out on my graph, I'm just going to plot a few points. Since we're starting with the equation negative 2 sine of 4 times theta, I'm going to be starting at the origin. Now one cycle is completed at pi over 2. So my ending point for the cycle is also going to be on the x-axis, so the y value is 0 at pi over 2. Now halfway between those 2 points, it's also hitting the x-axis. Then, since it's a negative 2 for an a value, I'm going to be going down to negative 2 first, halfway in between, and then up to positive 2, halfway in between. So this point is halfway in between the two zeros, and this point is halfway in between the two zeros. And then I'm just going to repeat that cycle all the way up to 2 pi and all the way back to negative 2 pi. Your final product should look something like this, keeping in mind that the start and end of each cycle will be on the x-axis, and the halfway point will also be on the x-axis. Halfway between those two zeros, the min is going to be, which is the a value, and the max is going to be halfway between the other two zeros. When looking at the cosine function, again on the same interval, my a value here for y equals negative 3 times the cosine of 2 times theta is negative 3, and my b value is positive 2, which means my amplitude is the absolute value of negative 3, so that's a positive 3. The period, which we said before is 2 pi over b, is going to be 2 pi over 2, because that's the b value. The 2's cancel, so the period is pi, which means it takes pi distance, pi radians, to complete one cycle. So the number of cycles completed between 0 and 2 pi are going to be 2, because that's the b value. So now I already have my interval written on my coordinate plane. On the y-axis, I went up to 4, only because we need to go down to negative 3 and up to positive 3. That's my a value, so that's how high they're going to be going. On my x-axis, the period is pi, so I need to have pi there. I'm obviously going up to 2 pi and down to negative 2 pi. Halfway between, I need that point, and then I skipped a line just to leave room for the curve. So when plotting our first curve, for the cosine function, you're actually starting at the a value. So since the a value is negative 3, I'm starting down here. Now, at the end of the cycle, so at pi, it's also going to be down at negative 3, which means halfway it's going to be up at positive 3, and then halfway between each of those 2 points are the zeros. Now the cosine curve is going to look something like this. It's not a parabola. You see how it's kind of flaring out at the ends. I'm going to continue this until I'm going from negative 2 pi up to positive 2 pi, and then do the same thing on your own and check that you have the correct answer. Your final product should look something like this. Now, when talking about transformations of the sine and cosine functions, we're going to start by looking at the parent functions, where x is representing the angle measure in radians. So the parent function for sine is going to be y equals the sine of x. The a value is the amplitude. It's changing whether or not it's being stretched or shrunk vertically. Now, if it's a negative a value, all that means is that it's a reflection over the x-axis. As the absolute value of the a value increases, that's what's vertically stretching it. As it decreases, so like anything that's in between 0 and 1 especially, that's when it's vertically shrinking. For both sine and cosine functions. Now, when looking at the h value, the horizontal translation, which we're talking about a phase shift here, it's important to understand that vocabulary. A phase shift, when I have something like, let's say, y equals the sine of x minus 2. Minus is going to mean that it's moving right. If it were the sine of x plus 2, plus is going to mean that it's moving left. The vertical shift, the k value, no special name for that, we're just calling it a vertical shift. Plus is going to mean that it's moving up, and minus is going to mean that it's moving down. We've talked about the midline in the past. Y equals k is the midline. So basically, if the sine function is being translated up 1 unit, that means the midline is being translated up 1 unit. So rather than the midline being the x-axis, y equals 0, like we've seen before, the midline would be y equals 1 in that circumstance. Finally, looking at the tangent function, we're going to graph this again on the interval from negative 2 pi up to positive 2 pi in radians. On my y-axis, I went up to positive 6 and negative 6 because my a value is negative 5, so I need to at least show that on the graph. I'm going to fill in a few pieces of information first. My a value is negative 5, and my b value is 1/2. Now for the tangent function, we're concerned about where there are asymptotes. One cycle goes from what to what, and what the period of the function is. We also need to know the a value so that we can figure out some of the points on the graph. Now the asymptotes are basically where the cycle goes from. The cycle goes from pi over 2b negative up to positive pi over 2b. So I'm just going to write that down here as a reference. Up to positive pi over 2b. So the cycle in this case is going from negative pi over 2 times 1/2 up to positive pi times over 2 times 1/2. So it's going from negative pi up to positive pi. So those are our asymptotes here. Now the period is pi over b. In this case, the b value is 1/2, so pi over 1/2. This is the same thing as saying pi times the reciprocal, 2 over 1. So the period is 2 pi. So we know that our asymptotes are going to be every 2 pi units. So I'm going to sketch in my asymptotes at negative pi and positive pi. Since this graph, the interval is only going up to positive 2 pi and down to negative 2 pi, we don't have to graph any other asymptotes. But it would be good to recognize that if it's going up to 3 pi, we're going to be finding halfway the distance between pi and 3 pi, because that would be the next asymptote if the period is 2 pi radians long. So in order to graph the tangent function, the first thing we're considering is the asymptote. So if we're looking at the asymptote of negative pi and positive pi, halfway between them is the first point at 0. After that, we're going to look at the asymptote and 0. Halfway between those 2 points, that line and the other point, is the negative a value. Well, if the a value is negative 5, that means that negative 5 is actually going to be positive 5. So halfway between negative pi and 0 is negative pi over 2, and we're going to plot negative 5, which is positive 5. Then halfway between this point and the asymptote is going to be our negative 5, because it's the positive a value. So halfway between, this is our point. Then we're just going to sketch it, and it will look something like that. Now, since we have to go up to 2 pi, I'm going to also plot the other points, but it's just going to be half of the curve on either side. So consider the fact that at 3 pi here, there's an asymptote. Halfway between pi and 3 pi is 2 pi. So at 2 pi, that's going to be my 0. And then halfway between pi and 2 pi is going to be my negative a value. So negative 5 is positive 5. So in this case, I'm only graphing this half of the tangent curve. Now on the other side, we're kind of going in reverse. So we're going from the asymptote at negative pi, and then again, considering that the other asymptote would be at negative 3 pi, our halfway point is negative 2 pi, so that's where the 0 would be. Now my negative a value would be over here, which means my positive a value is over here. The positive a value is negative 5, because the a value is starting off as negative. So this point is going to be down here. And then I'm just going to sketch that half of the curve. And then that would be our final product.